Hi, my name is John Saville, and in this video I want to talk about the British Postal System, which may also give some insight into how IPv4 works. I've had a lot of people ask about, well, how does basic IP communication work between machines in a network when I think about hybrid environments where I use the cloud? And so I want to really go through the basics of how networking works. And to do that, I want to talk about the British Postal System. Because let's think about it. I have a street. So I have a street, and on that street I have houses. Now, really a street is just a collection of houses that are in kind of close proximity to each other. I'm grouping them a certain way. Now, I'm at one of these houses. Let's say this is Baker Street, and I'm number 13. And I want to deliver a letter. So here I am, and I have a mail I want to deliver. Now I want to deliver it to 21 Baker Street. Probably would be 22, but whatever. Now, if I want to deliver a letter on the same street, I would deliver it myself. In England, the doors have a letterbox. It's a little slot in the door that you post the mail through. So I look at who I'm sending to. I'm sending to 21 Baker Street. I know I live at 13 Baker Street, so I'm going to deliver it myself. I would just pop over the road and deliver that. So that's great. I know that 21 was kind of the house ID, and Baker Street was the street ID. Now let's imagine I want to send it to 25 Butcher Street. So there's another street, let's say over here, and this is Butcher Street. And there's a house here, little letterbox, and this is 25. Now, I want to send a letter to 25 Butcher Street. So I look at the street parts of that, and I know, well, Butcher Street is not the same as Baker Street. It's not on my street. So I would not deliver that myself. So in England, what you have is you have post boxes. So on the corner of the street, there's this kind of post box, and they're red. And I would go and drop my letter off in the post box on the corner of my street. And then the postie, the postman, would come to the post box, and in this case, postie, this letterbox, is essentially connected to both of the streets. So the postman would pick up the letter and then go and deliver it to 25 Butcher Street for me. So it got there via a hop. Hey, I have my letter, I want to send it to a different street ID. So it goes via the post box, which is on my street, and it connects both of them together, and it gets delivered by the postman. So that's all that happens. Same street, I deliver it myself. Different street, I have this default place I send to, and then it gets delivered. Now, it could be way more complicated than this. There's other streets, long way away. This is Far Away Street. In this case, this post box isn't delivered directly connected to that street. So maybe what happens is, well, there's actually like a big main post office, a big hub. So what actually would happen is I would deliver my letter to the post office box. The mailman would pick that up, take it to the main post office. It might go to another depot somewhere else, where eventually it gets filtered down and is put in the post box on the corner of that street, where the local postman then delivers it to the house far away. So there are these hops that happen for my mail delivery. That's exactly what happens. I want to send a letter to someone, stick it in the post box on the corner of the street. If it's directly connected, the postie would directly deliver that letter. If it's not, go to the main regional post office, then maybe go to another post box in my region, maybe it goes to a bigger, more nationwide, which goes to a local post office, which goes to the post box, which goes to the house. And that's mail. There's hops. That's all it is. So that's streets. networks are exactly the same. I have a network, and off of the network I have computers. And we think of a house as a street address, 13 Baker Street. And there's more to it, we know that. Computers have an Ipv4 address. This Ipv4 address is 32 bits. Now, we don't generally write 1 zeros, we don't really understand that very well. So we write it as something called dotted quad, dot decimal. We break it into 4 digits. So we might say 10.1.1.20 is that machine's IP address. And this one is maybe 10.1.1.25. So these are on a local network together. Now, as a machine, now behind the scenes, each of these numbers is a byte, so 8 bits. If I want to send a packet to a machine 1.1.25, is it on the same network as me? So how does it know that? With a street, I can say, well, the 23 is obviously the house number, Baker Street, Butcher Street, that's obviously the street name. I can tell which bit is the house number, which bit is the street identifier. Well, an IP address is the same. It's actually broken up into 2 parts. One part is the network ID, that represents what network it's on, and then one is the host ID, its unique part within that network. How does it know which part is what? So it's something called a subnet mask. And often you'll see this thing as kind of maybe 255.255.255.0. And that's just the bits. Where it's a 1, that means that part of the address is the network ID. So there's this AND operation performed, a bitwise AND is performed. So you imagine if you actually converted all this to binary, 255 means all ones for that part. So all of that part, all of that part, and all of that part is the network ID. So that part, and that part is the network. So this is the network ID, 255.255.255.0. This part is the host ID. So here, I know, well, this is the network ID I'm on, and this is the host ID, my IP address. I want to send to 10.1.1.25. The network IDs are the same, based on that subnet mask. Now this can get very complicated. I'm showing you 255.255.255.0 because it makes it easy to understand. This may not be 255, it may not all be ones. It might be 254, 252, it varies. But computers don't care about that. They understand that just fine. As a human, it's hard to understand. Computers do not care. But it doesn't really matter. The point is, it's a way to identify which part of the IP address is the network, which bit is the host. So if I'm sending to a machine that is on the same network as me, delivering to a house that's on the same street as me, I deliver the packet myself. Hey, I want to send something to dot 25. I directly send it to there. Easy. Now imagine I have another network. And this obviously has a different network ID. Maybe this machine's IP address is 10.1.2.30. And it had the same subnet mask, 255.255.255.0, which means the first 3 parts is the network. That's the host ID. So I want to send a packet to 10.1.2.30. So I look at that and I say, well, the network is different. This is not my local network. I cannot deliver the packet myself. So I deliver the packet now to a default gateway. That's something that for any packet I can't deliver myself, by default, I just send it to. And this has its own IP address. So on my network, it would probably be 10.1.1.1. On this network, it's connected to both networks. It also has an IP address of 10.1.2.1. So I would send my packet to this router, switch, They do different things, but for now you consider it's connected. And it says, oh, okay, you're sending to 2.1.2.30. I'm connected to that. I will go and send that packet for you. Same as the streets. It's doing that delivery for me. And exactly the same way as the streets, I might have other networks. There are maybe other networks over here that are far, far away. And they have their own sort of routing devices. So when I'm trying to send to these completely different networks, maybe this is 10.48.33.5 is a machine on there I'm trying to connect to. Well, it may have to hop through multiple routers. They have a table that says this is where to go, the same as the post office. Says, well, hey, I'm trying to get to far, far away. Well, I know I need to deliver the letter to this as my next hop for that letter. This has a table that says, okay, for the regional address, because this is out of my local region, send to this main post office. Then it has a table that says, okay, we'll send to this post box here, and so on. Routers have exactly the same thing. So my packet goes between these various routers and finally gets delivered. So that's how the IP packets work. That's why when I look at a machine, if I do my IP config, you can see that I have an IP address, I have a subnet mask, and I have a default gateway. So if my machine I'm sending to is on the same network, I'm going to deliver it myself. If I'm delivering it to outside my network, normally I would just send it to my default gateway. And again, the machines behind the scenes are doing this bitwise AND operation to work out, based on the subnet mask and the IP, which bit is the network address, which is the host. And that enables me to deliver the packets. Now back to my house example. By default, I always deliver it to this post box. And it's going to take various paths and routes to get to my final destination. But what if there's somewhere I want to get to, that I want a different path to be taken? Maybe over here, let's draw over here, there's Mars. And Matt Damon in his little spacesuit needs some potatoes. Now, I could absolutely go and drop off my potatoes in my local post box. And then my local post box would send it to my local post office, which goes to some regional hub, which then sends it to the international hub, that sends it to the Milky Way hub, and we'll go and eventually get here. That would take a really long time. It's hopping around all these different places. And who knows how busy these are? My letter might sit at this post office for a day or two, because they're just busy with other people's letters. There's a latency, how long it's going to take to actually get there. Well, it just so happens on Baker Street, there's a little rocket. And he's got these little blasters, and I could go and deliver that mail. I have a different route. If I want to deliver potatoes to Mars, or anything else to Mars for that matter, it's not limited to potato shuttle, instead of delivering it to my post box, I know that, hey, if I want to get to something that's in Mars, I deliver it to the rocket place. And then the rocket place will fire off directly and deliver it very quickly, so it has a lower latency. Now, I may not have that route. This could be at my post box. My postie may go and know to deliver it to the rocket park. But I can specify different ways for things to get there. So latency, how long it takes to get there. And that can be influenced by the distance, can be influenced by the number of hops I have to take. It's influenced by how busy these things are, how long my package waits before it moves on to the next place. And so sometimes I have paths that are more direct. Who knows what the latency is going this way? Bouncing around, how busy they are, it's inconsistent. I know the latency. This rocket guarantees, it's really, really fast, it will always get there in 5 days. Pretty unlikely, especially if you've seen the movie, The Martian, you know, it takes a lot more than 5 days. But it's consistent, I'll always get the same. There's also bandwidth. How much can I send? Well, maybe here I can send as much as I want, it's giant trucks. Here maybe it's a smaller portion. So bandwidth is how much I can send. Same on the network. There's routes that bounce around, but when I'm sending a packet, imagine this is on-prem and I'm trying to get to the cloud. If I send it via the normal routes over the internet, it's bouncing through many, many, many different routers. They might be busy and my packet sits there for seconds. So my latency will be poor. Or maybe I have a dedicated connection. I have a cloud, or I have a network, and I actually have a dedicated connection from my network to there. So latency is now consistent, it's always the same. So it's taking this dedicated path. The bandwidth is fixed. I purchase a certain speed. It's exactly the same for networks. I have a latency. How long is the packet taking to get there? Over the internet, it varies. How busy are these switches? What hop? What direction is it going? If I do a dedicated connection, well, it's a private connection for me. It's always taking the same path. The latency will be consistent. And that's huge. That's really a key thing that I care about. So when I think about hybrid environments, the latency and the bandwidth, they're big deals. Hopefully you're following so far. You may have to rewatch this a few times. But let's think about something else now. Let's go back to just me wanting to deliver to 21. Now, in the street, houses are organised numerically. It's pretty easy for me to work out where 21 is. I can just go out into the street, look at the house numbers, say, okay, I need to go that way. But what if they weren't laid out in order? They just randomly put on the street. So one way I could do this is the street is actually just a logical construct. I pick the street name, I pick the house number. That's not a real physical attribute. A physical attribute would be like a GPS location. So one way to actually find 21 would be I could walk out into the street and I could shout out, hey, 21 Baker Street, what's your GPS coordinate? And the person in the house would come back out and shout out, hey, GPS coordinate, XYZ, whatever. I go, great. I get my little GPS tracker and I say, okay, I'm going to walk to XYZ. And I would get absolutely to that location. Postbox does the same. I still need to find the postbox. Hey, postbox, where are you? And it's got a little robot computer that's listening out for someone asking. It says, oh, I am at XYZ 2, whatever. Now, I don't shout out every time. I actually have a cache. I don't want to keep going out into the street and shouting. So once I've shouted once and I know, hey, 21, this is the GPS coordinate, I make a little note. Same for the postbox, I make a little note. So if I want to deliver to it again, I can look in my little notebook and just go and type it in directly and deliver the thing. This is also why we limit the number of houses in a street. If I had too many houses in a street, I'd have so many people shouting at the same time. No one would get heard. It would really slow things down. I'd start shouting out and someone else would interrupt me. So I'd have to wait. So that's why we limit the number of houses on a street. So there's only so many people shouting at once. And obviously this would be a horrible place to live if this is how it actually worked. Exactly the same on computers. The network card has something called a MAC address. This is a 48-bit address that is hard stamped into the network card when it's manufactured. So what actually happens is, to deliver the packets over the wire, I need to know the MAC address of this machine. And exactly what I just said happens. So the MAC address is not written as the dotted quad, it's a grouping of 6 hexadecimal digits. Hexadecimal digit is 4 bits, so 2 together. If I go and look, I can look at an ipconfig again, and I can see there's my MAC address. You can see there's the 6 groupings of the 2 hexadecimal digits, so 8 bits, 8 times 6, 48 bits. I need to find the MAC address of the machine I want to send to. So it does an address resolution protocol, ARP. It literally shouts out on its local subnet, hey, who is this machine? And he replies back, here's my MAC address. And then I can bundle up the packet on the Ethernet, send it, and it gets to that machine. Same way for the default gateway. Default gateway, what's your MAC address? Replies, that's how we actually transfer traffic. That's the key point. That's actually that's a physical thing. That's what's going on behind the scenes. A couple more concepts. This is great, these house numbers. I build a house, it's going to be there forever. I stamp it with a house number. But what about if I have houses that appear and disappear? Then you might say, what sort of wizardry is this? What houses appear and disappear? Well, imagine I have a campsite. And I have tents just spring up. I don't want to give every person who comes to my campsite an address that's theirs. They're only there for a week. I've run out of addresses. It would be impossible. So I have plots in my campsite. And this plot maybe has an address of 43, this one has an address of 44, this plot is 45, etc. So someone is driving down my street, they're camping and they say, I want to stop at a campsite. So they may shout out, hey, can anyone offer me an address? And the campsite owner shouts back, yes, I can offer you 45 Baker Street. And I can offer it to you for a week. And that person says, fantastic. So they go and they set up their tent. I really can't draw a tent very well. On there. And they can have that address for a week. So I could send mail to 45 Baker Street and it will get to that tent. Now after the week, the camp owner takes that address back unless they want to renew the lease of that campsite. But then they go away and I can give that to someone else. Someone else comes along and they get that campsite and they lease it again. Makes sense for these people that are just travelling. Only need it for a limited number of time. I can't give them a permanent address. Exactly the same thing on the network. Yes, I can statically give machines an IP address. But if I have a machine that's coming on the network temporarily, it's a laptop user. Hey, they're popping on. I don't have an IP assigned for them, so they shout out, hey, can anyone give me an IP address? And I have things called DHCP servers, Dynamic Host Configuration Protocol. And they have a range of addresses they can give out. Maybe this can give out 10.1.1.50 to 100. So it says, hey, I can offer you 10.1.1.51 for 8 hours. And they accept, acknowledge that. So they are now 10.1.1.50. At the end of the 8 hours, they lose that address. They can renew it. But the great thing here is if that machine disconnects from the network, they don't need that IP address anymore. It goes back, I can give it to someone else. So that's one way we can think about organising IP addresses. I don't have to statically configure it just for that machine the whole time. Machines come on, they get an IP address, they leave, they lose the IP address, I can give it to someone else. And that's very common. I don't like managing these IP addresses statically, so DHCP takes that management away from me. I just define the scope, the range. I can configure other things, and machines just get that as part of DHCP. One last concept. So going back to our campsite scenario, for example, or anything else. Actually, who I want to send the letter to is Clark Kent. I don't think I want to send a letter to an address. I want to send it to someone. Now, I don't know the address of Clark Kent. So what do? We go online and we do a lookup. Hey, show me the address of Clark Kent. There's probably not one giant registry that has everyone's name in it in the world. Instead, maybe it's a point, an entry where it says, okay, you're looking up Clark Kent. Well, there's a separate address book that has a link to all the people whose names is something Kent. So it redirects me to there, and then it says, okay, well, the letters beginning with C, there's this address book. So eventually, through a number of different address books, I get to, hey, here's Clark Kent, here's his address. So I looked up, based on the name, the address, because we're not good at remembering addresses. Very useful for campsites. The address book's constantly changing. Hey, I check in, Bruce Wayne is in this. Bruce Wayne would never stand a tent, obviously, I get that. But imagine, maybe it's a cool cave. Bruce Wayne checks in. Hey, for the next 8 days, create an entry in the address book that says Bruce Wayne is at 45 Baker Street. Exactly the same for computers. I don't remember IP addresses very well. This also has a name. Maybe this is a domain controller, DC1. Well, there's domain name services. It's someone I can go to and say, hey, what is the IP address of DC1? And it will respond. When I go and look on the web, www.saviltech.com, what actually happens is I have a local DNS server that I talk to on my network. They may have cached that result from the past, but maybe not. And again, these MAC addresses get cached. But the DNS entries, hey, www.saviltech.com, where is that? It has no idea. But there's a high-level DNS for com. And it says, okay, well, ask one of these servers where is saviltech.com. And it points me to the saviltech.com server. I then do a query to saviltech.com. Hey, what is the IP address for www? That's probably an alias, just another name for an actual web server. It says, well, here's the IP address. I can then go and talk to it. So domain name services is what lets me take a friendly human name, convert it to an IP address, and then I use address resolution protocol to convert it to a MAC address, and that's how we talk. So networks and the British Postal System are actually identical, exactly the same way they function. Again, you'd never want to live in these streets, lots and lots of shouting, but hopefully that makes sense. You get an idea of what's happening behind the scenes. Hey, I'm on the same street, I'll deliver the letter myself. I shout out, hey, what is your actual GPS location to find exactly where they are, and I can deliver it. They're not my local street, I'll deliver it to my post box. And through a series of hops, it gets to that target. I use an address book to work out, based on a friendly name, what is their address. There's a certain latency, how long it takes to get there, based on how busy other things are and the route it takes, and then a bandwidth, well, how much can it take? Same on networks. Hey, if it's on the same network, which is based on the IP address and the subnet mask, tells me which bit is the network ID. The network ID is the same. I'd use address resolution protocol, shout out, what is your MAC address? It tells me, I cache that in my ARP cache, and I send the packet directly via Ethernet. If it's on a different network, I send it to my default gateway, or I might have an alternate route potentially configured. I use friendly names, look those up with DNS to find out the IP address. I can use DHCP to give people IP addresses temporarily, they lease it, and then that runs out. So I hope this was useful. This is really designed as a kind of primer around networking, just the basics. It's very important when I think about hybrid environments, how the networking, why these dedicated networks can be important in terms of my performance and guaranteed sort of latencies. So I hope that helped. If you have any ideas for other things that you would like described via the British Postal System, or maybe we can think of other things, please just drop a comment. And I post an NT FAQ guide. I tweet when I do a new video, so please sort of join me on that. And I appreciate your time. Thank you.